It's once again time to head out and explore, and this time the destination is the source code of Elite Dangerous. Hello ladies and gentlemen, and welcome back to Elite Dangerous with Down to Earth Astronomy and to another episode of Worth a Visit. Today's destination is going to be a little different, because even though we are going to visit a very specific system, I want to talk more about the source code behind Elite Dangerous rather than the actual system that we're going to visit. But the system that I'm going to showcase today is called HIP 104643. And if we open up the system map, we can see here that the system is quite remarkable. Not only does it have a black hole, it also has a star with rings around it. In astrophysical terms, this is not uncommon. This would actually be something you would be seeing quite a lot of, because, this would be the state of a star before the planets were formed, and all the small rocks in the rings would slowly begin to clump together to larger and larger rocks until those rocks have a size where we begin to call them planets. But that's not what we're going to talk about today. As I said, we're going to visit the source code of Elite Dangerous, the background thing. And the reason why we can see something about this is when we drop into these rings, they are absolutely massive. Their outer diameter is over 300 light seconds. They're massive. And if we drop down into these rings, we can see some peculiar structures beginning to form. And more noticeably, you will notice that these rings are actually aligned in a grid. And they are what give this stacking point. Basically, there's a grid, and they are all stacked at the cross sections in this grid. And why is that? Well, to understand why this phenomenon happens, you need to understand the way that computers store numbers, because this is going to be very technical now. So bear with me. If it's too technical, try to enjoy the scenery in the background. But anyway, I'm going to try to explain it, and I hope you guys can follow. So, when a computer stores a number, you allocate a certain number of bits, so a certain number of 1 and 0s that you will use to store the number. And most commonly, you would use either 32 or 64 bits. Now, a 32 is what's probably called a single, and the 64 is called a double. Now, of course, the more numbers you have, either you can store larger numbers or you can have higher precisions. Because if you're just storing what is known as integers, meaning whole numbers, there's a certain hard cap to the largest number you can store, because there's a limited amount of space to store the number. But when you want to store decimals, what you then do is use what's called floating points. Now, I'm not going to go into too much detail with how floating points work, but in rough terms, basically, you can imagine this as being, you can freely float the decimal point between the numbers. So that means if you have a very small number, say 1 point something, I have a lot of bits left to store the decimal places after the decimal point. So I can have a high accuracy on my number. But as the main number increases, so let's say I would then want to store something that's up in the trillions, then suddenly I used a lot of my available numbers to store the large number. So there are less numbers available in to store the numbers after the decimal point. And this is what's happening here, because when you go drop in the middle of the belt, which is what's shown here, you can see a fairly tightly packed grid. But if I move out further in the ring, almost at the edge, which is almost twice the distance from the star, we can see the grid is much more spaced out. And what's happening here is, because these rings are so large, and the distance, the location of the rocks is stored in the Elite database as of course XYZ coordinates, but the origin of that coordinate system is at the center of the orbit, the object that the rings is around. So because we're so far away, a lot of our available bits are being used to store that large distance, because we're so far away. That means we're beginning to lose accuracy. And when we lose accuracy, they begin to snap into a grid like this. And this is what's causing this grid structure that we see in this system. I hope that makes sense, at least. That because we are so far away, we have to store a big number. Because we're storing a big number, there's not enough room to store the decimal points. And therefore we get this snapping of the grid because we begin to lose accuracy in the rock's position. So it's not, you could say it's a bug. It's just an effect of the inaccuracies of storing numbers in a computer, which is something that you, as a computer scientist or a software developer, have to work with, have to know how to work around, and when you can just do certain stuff and when you can't. But we actually have some similar effects other places in the galaxy. For instance, if we go here to the Eagle Nebula, many people have probably noticed this, but in the Eagle Nebula, there are stars, specific classes of stars, that are lined in very evenly spaced lines, and all those lines point back towards Sol. Now, you could imagine that this would be kind of the same problem, but it's actually not. It's related, but it's not the same. It's still related to accuracy. You see, the reason why these effects are occurring in the game is because that Elite has taken, or Frontier has taken, a lot of real data. They've taken a lot of catalogs of stars, and then they plotted them into the game. Now, that of course means that if these stars were measured inaccurately, then you would get those inaccuracies shown in the game. So what is happening here is when these stars was observed. Wow. Okay. Anyway, you can very easily determine the angular position. So it's easy to see if a star is slightly left, slightly to the right, or up or down. That's very easy to measure with a high degree of accuracy. But the distance is a lot more difficult. It's kind of like if you cover one eye and you try to determine the distance of something. It's easy for you to see if the object you're tracking is moving across from you, but it's difficult to look at the depth perspective of something. And that's the same problem we have here. We are basically looking with one eye because the things are so far away. So what's happened here is, because these stars were observed, the distance was hard to measure accurately. And again, because we have some inaccuracies, we get this snapping into a grid. But in this case, we only get snapping in the radial axis, so away from Sol, or away from Earth, because of course the angular distance we can measure at a high degree. So that was a quick overview of numerical accuracies in Elite Dangerous. And again, I recommend, if you're going out exploring and heading out in this direction anyway, come by the system and have a look and try to drop into the rings yourself and have a fly around. It's absolutely surreal to try and fly around here. But yeah, thanks a lot for watching. I really hope you enjoyed this video. If you did, give it a like down below and consider subscribing to the channel. And until next time, I will see you guys in space.